Hello everyone, in today's video we'll be talking about geometric sequences. Okay, so let's briefly talk about what a geometric sequence was. We already went over this in the very first video where I was talking about geometric and arithmetic sequences and series. But a sequence was a list of numbers, and the fact that it's geometric means that the terms go up consecutively by what's called a common ratio. So they get multiplied by a number every time. So let's give a quick example of a geometric sequence. So for example, 3, 9, 27, 81. This would be an example of a geometric sequence, right? The terms go up by 3, they get multiplied by 3 every time. Okay, so we're going to have some formulas, just like we did for arithmetic sequences. And the first formula is the nth term formula. Or actually, the first term is the common ratio formula. So how do we find the common ratio? Well, the common ratio, whose symbol is r, can simply be found by taking any term, an, and dividing it by the previous term, an minus 1. So for this example, the common ratio is we take any of these terms and divide it by the previous term. For example, I'll grab 27 and I'll divide it by 9. And of course, this is 3. Okay, so the common ratio here would be equal to 3. Okay, the next formula we have is the nth term formula. So the way you would find the nth term in a geometric sequence is by using this formula. An is equal to a1, or just a, times r to the n minus 1. So let's say I wanted the third term in this geometric sequence, right? So this is the first term, second term, third term, fourth term, and of course this is our a, right? The first term is the a term. So let's say we wanted to calculate the third term here. How would we do that? So let's draw a line here. How would we find term 3? How would we find term 3? Well, a3, or the third term, is the first term, which is 3, times the common ratio of 3 to the power of 3 minus 1. So our a3 will be equal to 3 times 3 to the power of 2. So 3 squared is 9, times 3 is 27, and we can see that, yeah, the third term is really 27. Okay, so that's how we can find the nth term. We'll briefly talk about where this formula comes from. So let's have a look at that. So our formula is this. An equals to a r n minus 1, right? This is the same formula we had above. So where does this come from? Well, let's say we start with the same sequence that we had on top. So it was 3, 9, 27, 81. If I want to figure out what term 3 is, as an example, I can do that by having a look at the first term and counting how many times it's being multiplied by the common ratio of 3. Okay, so if we want to find the third term, we would have to multiply the first term by 3 twice. If we wanted to find the second term, we multiply the first term by the common ratio once. So we always have the term we want minus 1, right? We multiply by the common ratio 1 less than the term number we want to find. So if we wanted to find the third term or fourth term, we would multiply by 3 times, right? And our common ratio is 3, so if we do 4 minus 1, that's 3 cubed, which means 3 multiplied by itself 3 times, right? So that's what this part of the formula means. This is taking, this is accounting for the number of times we are multiplying by 3. And of course, we're starting from the first term, so that's what the A is. All right, so that's the logic behind the formula. And that's actually going to be it for this lesson. In the next video, we'll again look over a whole bunch of problems I've prepared on geometric sequences. There is a additional section to this video. This section is extra. It is sort of like a bonus section. I don't have any questions on this next topic in the worksheet that I'll be going over in the next video, but I will still be going over this topic. So this is on geometric means. So we talked about arithmetic means a couple videos ago. Now we're going to talk about geometric means. So let's start with an example. Let's say we have a geometric sequence that goes like 3, 6, 12, 24, 48. So every time we are multiplying by 2, right? So this is definitely geometric because to get the next term, we multiply by the same number every time, right? So multiply by 2 every time to get the next term. Okay, so what does a geometric mean? Like, what is its meaning? A geometric mean, if I say to find 3 geometric means between the number 3 and 48, that means I want 3 numbers that are evenly spaced out between 3 and 48. And I mean evenly spaced out in the sense that they're all separated by the same common ratio r. Okay, so let me draw that here. They're all separated out by the same common ratio r. So times r for all of them, right? So meaning I want to find 3 numbers so that the first one and the second one, right, our first term and the second term, are different by this factor of r. Our second and third term are also different by this factor of r. Our third and fourth term are different by a factor of r, and fourth and fifth term are also different or differ by that factor of r. So that's the meaning of a geometric mean. Now we have a formula for that. So the formula to calculate the geometric mean is really a formula to find r, and then using r we can find the terms. So that formula is as follows. We'll talk about why we have this formula in a second. N plus 1, and here we have the, let's call it the last term, divided by the first term. So I'm going to give try to give you guys the intuition for where this formula comes from, but this is one of those things where you'll have to just think about it for a little while just by yourself, and it'll eventually click. Okay, so here's the logic behind this formula. We really have to keep in mind the definition of the geometric mean. So we want to find some number of numbers that are evenly spaced out between 2 other numbers, right? So that each number is separated by a factor of r. Okay, so if we take the last number, 48, and divide it by the first number, that's going to give us the total multiple or the total difference between the 2 numbers in terms of a factor. So it'll tell us essentially by what factor 48 is larger than 3. Okay, so let's do 48 divided by 3. That's going to be 16. So that's telling us that 3 times 16 will be equal to 48, right? So in order to go from the number 3 to 48, we have to multiply by 16. Okay, so the next step is going to be fairly easy. We know the total multiple difference between 3 and 48, right? That's 16. And we can see that that factor of 16 is separated out over 4 common ratios, right? If we want to find 3 geometric means between 3 and 48, we are trying to find numbers so that when you multiply 3 by r, you get one of the numbers. When you multiply 6 by r, you get the second number. When you multiply 12 by r, you get the fourth number. And when you multiply 24 by r, you get the last number, right? So we can see that in order to find 3 geometric means, we are multiplying by r 4 times. So this 16 is equal to r to the power of 4. Where did the 4 come from? Well, the 4 is, if we can sort of see the pattern, it's always one more than the number of geometric means we want to find. Okay, and in order to solve for r, we have to take the n plus 1 square root on both sides. So we get that r is equal to n plus 1, the n plus 1 square root, or n plus 1 root of 16. And how did we get the 16? The 16 was the last term over the first term. So this gives you the common ratio, and the n here is the number of geometric means we want. Okay, so that's the n. Okay, we'll do a quick example of how to use this formula in this video, just because I don't have any problems on this in the next video. So let's go ahead and let's do this problem. So find 4 geometric means between, now I have to make sure that this works, so give me a second. That's 1, 2, 3, 4. Okay, so between 2 and 486. Okay, so how can we find 4 geometric means between 2 and 486? So first we'll find that common ratio, right? The ratio that we multiply by to get to the next term, and then we'll find the actual numbers. So I'll write out that r is equal to, now we want 4 geometric means, and our formula was, let's write the formula first. So last term over first term. Okay, so now let's plug in the numbers. Our n here, remember n was the number of geometric means we wanted to find, and that's 2. That's 4. So we'll do 4 plus 1, or 5. The last term here, the last number is 486, and the first number is 2. So let's see if we can compute this. So what is 486? Well, 486 divided by 2 we can do in our head, so that's going to be 243. And we want to take the fifth root of 243. So let me do that with my calculator. Fifth root of 243. And this is going to be equal to 3. So we got that r is equal to 3. Now, how do we find the actual geometric means? Well, we started with 2, right? We want 4 geometric means between 2 and, so between 2 and 486. In order to get to the first geometric mean between 2 and 486, we grab 2 and we multiply it by 3, by our common ratio. So that's going to give us 6. To get the next one, we grab 6 and we multiply it by 3, so multiply it by the common ratio again. So that's going to be 18. And then 18 times 3 to get the next one, and that's 54. And then 54 times 3 to get the next one, which is 162. And so those are the 4 geometric means. And just as a check, if we do 162 times 3, we should get 486, which I've just tried it, and we do. Okay, so the 4 geometric means are 6, 18, 54, and 162. Okay, so that's going to be it for this video. If you guys have any questions, feel free to leave it in the comment section and I'll do my best to answer them. All right, see you guys in the next video.